Okay guys, here's the second booklet on graphing polynomials, and it is the last booklet of our entire polynomials unit. So we're going to take a look at page 2, example 3 first. When you're going through the first page, just kind of take a look at the notes briefly if you need to. But you're basically looking for a few things when it comes to graphing, and this example is going to do that, except for the first page is fully factored for you. So we're going to have to look at this one and see what we need to do. So steps that I would say that are not really in the booklet that you might want to focus on here and maybe write them down. Number 1 is to factor if you need to, which the whole first page is done for you. Step 2 is your intercepts. Okay, and be careful with your y-intercept, right? Okay, because for the y-intercept, obviously we know that x equals 0, but it doesn't necessarily mean that it's the constant on the end, right? Because everything is factored out. So you're gonna have to do a little bit of bed mass with the y-intercept. Okay, and the third thing to look for is the multiplicity, which we talked about in the last video. Okay, so when you graph your x and y intercepts, then you want to look at your x-intercepts and see what the multiplicity is. Is it going all the way through? Is it bouncing back? Is it flattening out as you go through? Okay, you can still look for, kind of as an option, basically your degree and behavior, right, which comes from your leading coefficient as well, whether it's positive or negative, and that can help you draw out the graph too. Okay, so when we're drawing these graphs out, we aren't necessarily going to be looking for the sign diagram anymore. Okay, we're going to basically just graph our intercepts, look for the multiplicity, and then discuss the end behavior as we go. Okay, so one x-intercept in example 3 is 1, but we don't have the factored form. If one of the x-intercepts is 1, remember that that's the same thing as a 0 or a root, which means that we can do synthetic division to get the rest of our factors, okay? So if one of the x-intercepts is 1, that means that one of our brackets is x minus 1. To find the rest, we're going to do synthetic division. Okay, so we're going to go 1, 1, -5, and 3 from our polynomial up top. Quick synthetic division review here. Adding there. Okay, and then we got -3, and then -3 there, and we end up with 0. Should end up with 0 in the end, and if you didn't, then you would have made a mistake on your way through. All right, so x minus 1 is one of our brackets, as we said above. Now we end up with x squared plus 2x minus 3, fully factored, is equal to x minus 1 times x plus 3 times x minus 1, which if you notice, these two match each other, so you got x minus 1 squared times x plus 3. Okay, so if you need to pause the video or do whatever you need to do, I'm going to erase this part, and now we're going to look at actually graphing it onto our graph. Okay, so I'm going to keep this on the bottom, but I'm just going to erase the work I did here. Keep it in your booklet, obviously, for your own space. All right, so now I want to look at the actual graph. All right, well, I've got the x-intercepts now at this point. I've got an x-intercept at 1, and I've got an x-intercept at -3. Okay, so those are my 2 x-intercepts that I have so far. I do have the multiplicities of both, right? Multiplicity of 2 on 1, so whatever happens in that case is going to bounce back up or bounce back down, depending which way I'm going. And -3 is a multiplicity of 1, so it's just going to go directly through. When it comes to end behavior in this question, that is dealing with x to the 3, right? So I'm going to have an odd degree, which either goes down in 3 and up in 1, or vice versa. The leading coefficient is positive, so I'm going down in quadrant 3, up in quadrant 1, and finally the last thing I need is my y-intercept, which is when I let x equal 0. You could do that right at the top, which is nice. Okay, and that's just equal to 3, but just to practice for that front page if you need to, doing it on the bottom here, this is optional obviously. You got 0 minus 1 squared times 0 plus 3. This is -1 squared, which is 1, times 3, and there's 3 again, so it's equal to in both cases. All right, so now with my multiplicity and my end behavior, I know I'm down in 3, so I'm going to go down up to here. My multiplicity in this case for -3 is 1, so I'm going to go directly through. Remember to go above or below the y-intercept depending on where it is. So in this case, I want to go above it and go down into the y-intercept before I get to my next x-intercept. You reach your next x-intercept, you check the multiplicity of that one, which is 2. So we're going to bounce back up into quadrant 1. All right, so again, remember our steps. Factor if we need to, which we did using synthetic division. Get your x and y intercepts. You might need to do a little bedmass for the y-intercept, or if you have this question, you can get it directly from there. And then with the end behavior, depending on your degree term, right? So we've got down in 3 and up in 1 because it's a positive coefficient and an odd degree. Okay, so the next example below is example 4 on the same page, and it's asking you to state an equation for f of x, and it has to follow all of these things that we have below. So it needs to be a polynomial of degree 4. It has a 0 at 2 with a multiplicity of 3, a 0 at -5, and a y-intercept at 80, okay? So here is what we're looking for basically. Everything we have right now is almost there, all right? So we got f of x is equal to, I think in the booklet it has y is equal to, it's fine, either one is okay. And we have x minus 2, right? Because it's a 0 at 2, we always flip the sign, multiplicity of 3. Then we have a 0 at -5, flip the sign. In terms of the multiplicity of this one not given, we have a degree 4 in this question, right? Well, if this one's already 3, and we would have x cubed in that case if we FOILed it out, times x, there's your x to the 4. So we know for sure that it's a multiplicity of 1. So basically you need to figure out how much is left in your degree. So if this was a degree 5, you would put a 2 here instead. The y-intercept is 80, which we know doesn't matter when it's factored out because we don't have a constant term, right? But what we don't know, what we don't have, is the number out front. If you notice on the first page, everything that was factored out had a number out front or actually example 2 didn't, but example 1 did. So basically we're just trying to figure out what is this coefficient here. So let's give it a value of a. We're pretty used to having a out front, so let's keep it consistent with what we've done all year and in grade 11 as well. Okay, so now we have almost everything. We need to solve for this value a in order to get the full polynomial. To do that, we could substitute a point in for everything, right? We have a y value here, we have an x value there, and we could solve for a. Do we have a point? Yes, we do. Technically, we do with the y-intercept, so we're going to substitute 0, 80 into the equation, and then we can solve for a. Okay, so y is equal to is going to be 80 equals a times 0 minus 2 cubed times 0 plus 5. And then we just do bedmass here. We get a times -2 cubed times 5. 80 is equal to a times -8 times 5. So we're going to divide by -40 on both sides, right? Because this is -40 here. And then you end up with a equal to -2. Okay, so that means that that is your value outside your bracket. And your final answer in this case, I hope this isn't too far down here, therefore we got f of x is equal to -2 x minus 2 cubed times x plus 5, and that is your full polynomial for example 4. Okay, last example for this video, and I'll leave the rest to you guys. Anything I've skipped over, you can do on your own and just check the notes after, is page 3, example 5. So now we've got a picture of the graph, and they want us to determine the equation p of x in this case, all right? So very similar to example 4, this time we just have to use the graph to help us out, all right, and understanding the multiplicities and the zeros and all that kind of stuff. So in this case right now, we've got p of x is equal to, we don't know the a value, which is very similar to the last question. We have a 0 at -3, which always gets flipped in the bracket. We have a 0 at 2, which is x minus 2. For the multiplicities of both, this one goes directly through the 0, so the multiplicity would be 1, and then this one goes to 2, bounces back up, so in this case, it is squared. All right, so we got to figure out a, we got to substitute in one of the points on the graph. It doesn't always need to be a y-intercept, it seems to be a common one that they give you, but it could have been a random point somewhere else that is not an x-intercept, okay? So do not use an x-intercept, but you can use any other point. So in this case, obviously the y-intercept is pretty easy to see. So we're gonna substitute in 0, 24 into the equation. All right, so we got 24 is equal to a times 0 plus 3 times 0 minus 2. 24 is equal to a times 3 times -2 squared. 24 is equal to a times 3 times 4. You're going to divide by 12 on both sides, and a equals 2. And therefore, p of x at the top here, you can write it on the bottom, doesn't matter, is equal to 2 times x plus 3 times x minus 2 squared. And there is your full polynomial. Okay, so in this booklet, you've noticed some pretty common trends here, right? Remember that we're always looking for our zeros in the x-intercepts. We're looking for the y-intercepts. We're looking to see if it's fully factored, and if it's not, we need to factor down with synthetic division and then graph the graph. If we're given a graph or given some information, just throw it into factored form every time. It's way easier to do it that way, just right into the brackets that we have. And then finally, you're looking for multiplicity and end behavior and all those things that might be important to the question. And it just depends on what type of question you're looking for. But now you basically have a tool set with all of these different characteristics that can help you either solve an equation or graph a graph if we're going the other way.